Let's take a look at finding confidence, calculating confidence intervals. Confidence intervals, we can't be certain of a population or parameter of the entire population's worth of data. So we had a confidence interval and say we're 90% certain that the deviation or whatever is in these two values. Think about standing on the scale. You might scale in the morning and say I'm 90% certain that my weight is between 150 and 152 pounds. We're not exactly certain until we actually do it and stand on that scale, but we have kind of a range of values in our head, and that's very much the same for this type of confidence interval. We're trying to find the range of values that the actual population statistic would be very certain to be in between. So we have a simple sample of size n drawn from a population whose population standard deviation is known to be 5.3. The simple mean, x bar, is determined to be 34.2. In order to find a confidence interval, the first thing we must do is find the margin of error, or what I like to call ME. Error uses the formula, the z value, which is a constant dependent directly on how confident you want to be, times the standard deviation over the square root of n. Well, let's go ahead and fill in 5.3 based on the problem given. It defines it right in the statement. We know that n, or the number in my sample, is 35. Where do I get this z value from? If you look on page 410 of your text, you'll see the level of confidence and the critical value, or z alpha over 2 value, given in table number 4. 90, 95, and 99% are the most two common z values, so that's what we have for a z possibility. Now I'm 95% sure, giving me a z value, looking this up on the table, of 1.96. Now I'm going to go ahead and take out my calculator here. Here's my little simple Windows calculator, and I'm going to say 5.3 divided by 35 square root. I want the square root of 35. Then I'm going to push equals to evaluate that fraction and multiply that by 1.96. This gives me a margin of error of about 1.76. Now, in order to find my confidence level, or my confidence interval, I want to take the mean and subtract my margin of error to get the lower end point, or the lower value. So let's see, 34.2 minus 1.76, 32.44. And I want to add my margin of error, on decimal point, to get my top value. 34.2 plus 1.76 gives me 35.96. Now there are several ways to write a confidence interval. Since you're typing them, it might be very helpful to write them using their parenthesis notation. We write the lower end first, and then the upper end separated by a comma in parentheses. That will allow you to very easily type out the confidence interval. The same concept can be used if we adjust the confidence level parameters just a little bit. For example, if you look at part B, the only thing I'm changing is my sample size of n. My z value stays the same, 1.96. My standard deviation stays the same, and the only thing that's changing is that number in the sample, or 50. So I could go ahead and take my calculator out. I'm going to clear it out just before I start, just to be sure. 5.3 divided by 50 square root is equal to 0.7495, which I want to multiply by my constant. Notice I didn't change the level of confidence. It's still 95%, so that constant is still the same, giving me a slightly smaller margin of error. which does make practical sense. If you increase the sample size, you will be more certain of your results, which results in a smaller margin of error. I then just subtract that margin of error from the mean, and add it to get my new sample size, or my new confidence interval. The same process will be completed several times, depending on, you're going to use the same formula for margin of error and confidence level, just depending on the actual values. Well, how is your sample size changing? How is your confidence level changing? How might that increase or decrease the confidence or the margin of error? And think about it in the practical sense. Now remember, this formula is only good if we know our data is normally distributed, or if the sample size is over 30. So if we want to use this particular formula with the Z values for confidence, we have to either know our formula or know our distribution is normal, or have a sample size greater than 30.